AC generator. Appliances like fans, lights, etc. need electricity to run. But how is this electricity produced? It is done by an electric generator. A generator is a device which converts mechanical energy into electrical energy. A generator differs from a motor because a motor converts electrical energy into mechanical energy. Here, we will study about the AC generator. The principle behind the working of generators is electromagnetic induction. When an electric conductor is moved through a magnetic field, the electric current flows in the conductor, whose direction can be found by using the Fleming's right-hand rule. This is the schematic picture of the AC generator. The field magnets produce a magnetic field. The conducting wire loop ABCD is placed in the magnetic field. The arm CD is always in contact with slip ring S1, and arm AB is always in contact with slip ring S2. Brush B1 is placed in contact with S1, and brush B2 is placed in contact with S2. A shaft is connected to this assembly. Through the brushes, the external circuit is connected. Initially, the coil is in the vertical position, that is 0 degrees, so no flux is cut and hence, no current flows in the coil as we can see from this graph. By the mechanical force, the shaft starts rotating, say in the clockwise direction. So the armature coil also starts rotating. Hence, the flux is cut and current is induced in the coil. By Fleming's right-hand rule, we can find the direction of the current in the arm CD. The thumb coincides with the direction of motion, that is, upwards. The first finger shows the direction of the magnetic field, so the second finger shows us the direction of the current, that is, from C to D. Next, we move towards the arm AB, but we can see that the direction shown by the thumb does not coincide with the direction of the motion. So we rotate our hand, and the directions coincide. Now the thumb gives the direction of the motion. The first finger shows the direction of the magnetic field. Hence, the second finger gives the direction of the current from A to B. So the current flows from arm AB to arm CD. As the coil reaches the horizontal position, that is 90 degrees, the flux cut is maximum. So EMF induced is maximum, and hence the current, as can be seen in this graph. Now, the current enters the external circuit as S1B1, which becomes positive and leaves the external circuit at B2, which becomes negative and passes through S2. During this position, arm AB faces the North Pole, and arm CD faces the South Pole. As the coil reaches the vertical position, that is 180 degrees, the flux cut is 0. Hence, the EMF induced is 0. Again, the coil starts rotating. When it reaches the horizontal position, that is 270 degrees, the EMF induced is maximum. We can see here the two positions of the coil. Initially, the arm CD was facing the South Pole, but now it is facing the North Pole. Even the arm AB, which was initially facing the North Pole, now rotates to face the South Pole. Also, the current is flowing from arm DC to arm BA, but B2 is still in contact with S2, and B1 with S1. So the current enters the external circuit from B2, which becomes positive and leaves the circuit at B1, which becomes negative. Hence, the direction of the current is reversed, and we can see the negative half cycle of the waveform. As the rotation continues, the coil reaches the vertical position, that is 360 degrees, and the current induced is 0, as we can see from this graph. Let us see this again. Initially, the coil is at 0 degrees, hence no current flows. When the coil reaches 90 degrees, the current produced is maximum and from arm AB to arm CD. Current enters the external circuit through slip ring S1, brush B1, and leaves the external circuit through brush B2 and slip ring S2, and we get the positive half cycle of the waveform. When the coil reaches 180 degrees, current produced is zero, which is seen in the graph. Now, when the coil reaches 270 degrees, the current produced is again maximum, but now it flows in reverse direction, that is, from arm CD to arm AB. It enters the external circuit through slip ring S2 brush B2 and leaves the external circuit through brush B1 and slip ring S1. Hence, we get the negative half cycle of the waveform. Again, when the coil reaches 360 degrees, the current induced is zero. This continues with every rotation of the coil. As the direction of current alternates every half cycle, it is called alternate current.